Good morning, Geometry A. Today we're going to be talking about 7.5 in the book, which is on page 398. It starts on page 398, so if you'll turn there. And today we're doing trapezoids. So here's a few definitions for you. First we have trapezoid. So our trapezoids are quadrilaterals, whereas the shapes that we looked at in the last section, like the rectangles and the rhombuses and the squares, those were parallelograms. So these are not parallelograms, these are quadrilaterals. Trapezoids are quadrilaterals, which just means they have four sides. So trapezoids are quadrilaterals and they have exactly one set of parallel sides. Only one, no more than one set of parallel sides. So trapezoids have bases, whereas triangles have, a triangle has one base. Trapezoids are going to have two bases, and the bases are the parallel sides, and the legs are going to be the non-parallel sides. So I'm going to erase this now, and we are going to keep going. Okay. All right. So, if I was to draw a trapezoid here, okay, something like this. Okay. This is going to be a parallel side, and this is going to be a parallel side. Notice my parallel sides are not congruent. If they were congruent, we would not have a trapezoid. Okay. So this is a base up here. Here's a base, and this is a base. Whoops. Can't spell today, sorry guys. Base. And this is a leg over here, and this is a leg. So a couple of important things to know. Your bases are not going to be congruent. Your legs may or may not be congruent. Sometimes they're not going to be congruent. Sometimes they are. All right, so these angles down here are called your base angles. This is just like on a triangle. And then we have more base angles up here. Sometimes these base angles will be congruent, and sometimes they won't be congruent. When you have an isosceles trapezoid, just like isosceles triangle, but we're going to have an isosceles trapezoid. Isosceles trapezoid. Please don't shake the table. Trapezoid. Okay. Isosceles trapezoid is going to mean that our legs here are congruent to each other. And just like in an isosceles triangle, when you have legs that are congruent, that means these angles are congruent. It also means our other base angles are congruent to each other. And since it's a quadrilateral, we know that all these inside angles have to equal what? 360 degrees total for the whole inside. Okay. Let's see here. All right, so we have a few theorems to look at, and the first one is called the isosceles trapezoid base angle theorem. It's on page 399 at the top, and this says that if a trapezoid is isosceles, then each pair of base angles are congruent. And we just did that. Base angles are congruent. That's what we showed with this isosceles trapezoid. The next theorem says isosceles trapezoid base angles converse. And that says if you have a pair of congruent base angles, then your trapezoid is isosceles. The next one says isosceles diagonals theorem. So we haven't done that one. Let me put that up here. All right, as we draw our diagonals, not a very good job there. I'm gonna redo this one, sorry guys. As we draw our diagonals here in our trapezoid, what the isosceles trapezoid diagonals theorem is going to say is that these diagonals are going to be congruent to each other, okay? So this one here, this whole diagonal is congruent to this whole diagonal. So if you know that if you're given a figure and it has nothing marked on it except the diagonals marked congruent, then you know that it's an isosceles trapezoid. So automatically you can mark your base angles congruent. So, all right, let's move on. Let's see here. There's another theorem on turn the page to page 400, and we're going to do the next theorem, and this is called the trapezoid midsegment theorem. And you might remember midsegment from our last chapter, where we did midsegments of triangles in chapter 6. Now we're going to do midsegments of trapezoids. So it's the same and a little bit different. All right, and this green does not like to erase. Okay. All right, so in a triangle, remember this, in a triangle, if we had a triangle and we were trying to find our midsegment of our triangle, we found the midpoint of this, right? And the midpoint over here, and we connected them. Then to find the value of this, it was 1/2 the base, right? Wasn't this for triangles? 1/2 of the base was our midsegment. Okay, so it's going to be a little bit different for trapezoids, but it's the same basic concept. So here we have our trapezoid. Okay, so to get our midsegment, yep, you still put it in the middle of each segment. So it would have been like this over here. Okay, so we're still finding the midpoint of each segment if we're asked to draw it. However, our formula is now going to say base 1 plus base 2. Okay, so we're going to take the length of this base, we'll call it base 1. And we're going to take the length of this base, we're going to add them together, then we're going to take 1/2 of that, okay? And you can put this 1/2 at the front or the back. And remember, you can also just divide the whole thing by 2 if that makes more sense. So it's 1/2 times both of the bases added together. Easy so far? All right, so let's see what else we need to do in this chapter. Okay, we have a few more theorems. The next thing we're going to talk about is kites. So, let me erase this. We'll get to kites. All right. A kite is a figure. It's going to be a quadrilateral. All right, and it's going to have 2 sets of congruent sides. So let's see, 2 sets of congruent sides. However, unlike any of the other shapes we have done in this chapter, these sides are not going to be opposite from each other. They are going to be adjacent to each other. So those 2 sides are going to be congruent, and these 2 up here are going to be congruent. So for it to be a kite, we have to have adjacent sides congruent. Okay, let's see. We have a kite theorem, kite diagonal theorem. So if I was to draw the diagonals of a kite, any kite, okay, there's a few things that we need to take note of. One, the diagonals are perpendicular bisectors, okay? They are perpendicular kites. So when you put the diagonals in there, they're going to create this 90-degree angle right here. Now, can you close that door, please? Then, the next thing you need to take note of is the kite opposite angles theorem. So if you have a kite, then your opposite angles, one set, only one, not both, is going to be congruent. So looking at this, which set of angles do you think is going to be congruent? It's definitely not going to be these, because we can tell by looking that this angle here is much smaller than this angle up here. But these two are going to be congruent. Okay? All right. I think that may be it for the notes. I'm going to put up another video and we're going to work some practice problems. But this is all of the notes for now. This diagonal here does not bisect the angles evenly. And we know that it doesn't because these two are different angles. So it doesn't bisect them. This section is not equal to this section. But it does create a perpendicular intersection right here. Okay? Stay tuned for part 2.